Greetings to all. This is Vaishnavi, Assistant Professor, IT Department from SNS College of Engineering. Now we are going to see about the contiguous memory allocation in operating systems. First one, contiguous memory allocation. The main memory should accommodate both the operating system and the different client processes. Therefore, the allocation of memory becomes an important task in the operating system. The memory is usually divided into two partitions, one of the resistant operating system and one for the user process. We normally need the several users process to reside in the memory simultaneously. Next one, therefore we need to consider how to allocate the available memory to the processes that are in the input queue waiting to be brought into memory. In adjacent memory allotment, each process is contained in a single contiguous segment of memory. That is, we have the diagrammatic representation for the contiguous memory allocation, that is process and the memory blocks. Here in memory blocks, some of the blocks are filled. Next one, each process is contained in the single contiguous section of memory. Here we use two methods, namely fixed partition method and the variable partition method. Now we are going to see about the first one, fixed partition method. We divide the memory into fixed size partitions where each partition has exactly one process. The drawback in memory space unused with the partition, that is example when the process size is greater than the partition size. Next one, the second partition method, that is variable partition method. Divide the memory into variable size partitions depending upon the size of the incoming process. Next point, when a process terminates, the partition becomes available for the another process. Third one, as the process complete and leave, they create the holes in the main memory. Hole, that is block of available memory. Holes of the various size are scattered throughout the memory. Next one, dynamic storage allocation problem. How to satisfy the request of the size is equal to n from the list of the free holes. We have the solution, that is first fit, best fit and the worst fit. First fit, allocate the first hole that is big enough, that is called the comes under the first fit. Next fit is the best fit, that allocate the smallest hole that is big enough. Must search the entire list unless ordered by the size and then produces the smallest left over the whole. Third fit is the worst fit. Allocate the largest whole. Must also searches the entire list, produces the largest left over the whole. Next point is first fit and the best fit are the better than the worst fit in the terms of storage utilizations. Next one is fragmentation. In fragmentation, we have the two types. First one, external fragmentation, and another one is internal fragmentation. Now we are going to see about the external fragmentation. This takes place when enough total memory space exists to satisfy the request, but it is not contiguous. Next, that is storage is fragmented into the larger number of small holes scattered throughout the main memory. Second fragmentation type is the internal fragmentation. It allocated the memory may be slightly larger than the requested memory. Here we have the diagrammatic representation for the internal fragmentation. Next, we are going to see about the example for this one. If they have the whole is equal to 184 bytes, process size is equal to 182 bytes. We are left with the holes of only the 2 bytes. The difference between the whole and the process size is 2 bytes. Next one, solution. Merge the adjacent hole together and the compaction. Move all the processes towards the one end of the memory hole towards the other end of the memory, producing the one large hole of the available memory. Here we have the 3 points. That is, this scheme is expensive as it can be done if the relocation is dynamic and done at the execution time. Next point, permit the logical address space of the process to be non-contiguous. Third one, this is achieved to the two memory management schemes, namely the paging and the segmentations. Thank you.